In this question, we see there is a cart, and it's hanging by a mast that passes over a pulley. And this thing here is the pulley. And the purpose of a pulley is just to change the direction of the force. It does nothing special besides just redirect the force. So we have a hanging block. And so once this thing is released, this thing, of course, experiences a force of gravity and it will cause the cart to move to the right. The pulley has no friction and known as negligible mass, so we don't have to worry about that. Must determine the change in momentum of the cart as it is pulled across the surface from the moment's release from rest, so that means V0 equals 0, until immediately before it hits the cart. So we know V0 equals 0. The thing is going to accelerate. So what measuring devices will we need to determine the change in momentum of the cart? Well, let's start off by just defining change in momentum. So delta P is m delta V. And so we are going to need, we are not given the mass, so we need the mass. So we have to find some way to get a mass. So choice A doesn't provide that. The second one does. We've got a mass balance and a mass balance. So that will allow us to get the m. Well, the delta V, delta V is V minus V0. And V0 is 0, so delta V equals V. So we need to find that final velocity. Well, we know the average velocity is delta x over delta t, and when the acceleration is constant, the average velocity is also the final plus the initial divided by 2. Well, if delta x over delta t is v plus v0 over 2, and v0 is 0, then delta x over delta t is v over 2, and that final velocity then is 2 delta x over delta t. So we need a way to get the change in time, and we need a way to get the distance. So we need some kind of timer, and we need like a meter stick. So we can see, since we don't have a meter stick, that takes choice B out. And if we look at choice C, we see we have all three of those things. So it looks like C is our answer. And a force probe. Turns out we don't need a force probe that are needed. We don't need a force probe to do that. So that's why choice C is our answer.